All right, problem 5. Consider the differential equation dy dx equals y minus 1 over x squared where x does not equal 0. On the axes provided, sketch a slope field for the given differential equation at the 9 points indicated. All right, we want to do on this one is I'm going to be looking for a few patterns here. First of all, when x equals 0, we are going to have a slope that is undefined. So when x equals 0, which would be this line right here, this line right up here, we definitely don't want to have anything going on because the slopes are undefined there. So just do not put anything there. All right, then I notice that when y equals 1, my slope is going to be 0 because 1 minus 1 is 0, of course. So when y equals 1, I'm going to have slopes of 0. And again, we're not going to put anything in the middle because my slopes are undefined there. Okay. Excuse me. Now from here, I'm just going to go point by point. I'm going to start with the point 1, 0. So if I do, I'm just going to actually go over here so you can see what I'm doing. dy dx, which is the slope, is going to be 0 minus 1 over 1 squared. That's going to equal negative 1. So the slope here needs to be negative 1. Okay, the next point I'm going to do is 2, 0. dy dx will equal 0 minus 1 over 2 squared, so that will equal negative 1/4. So it's going to be negative again, but it needs to be quite a bit flatter than that one. So notice I didn't make it as steep as that one. Right, now I'm going to bump up to 1, 2. No, actually I think I'll do negative 1, 0. We'll just get all those ones done. So I'm going to get dy dx is equal to 0 minus 1 again, and then it's going to be over negative 1 squared. And that will once again give me just negative 1. So the slope at this point is exactly the same as the slope at 1. So we'll try to draw the same slope line on that one. Okay, then I'm going to pop up, let's do 1, 1 next. dy dx, and that is going to equal, let's see if I plug 1 in. Oops, I don't really need to do that one. I meant to do 1, 2. How about? So I'm going to have 1, 2. This is going to be 2 minus 1 over 1 squared, and that will give me 1. So it's going to look like this one down here, but it's just going to be headed in the other direction. So there we go. And then I'm now going to test 2, 2. So I'll get dy dx is equal to 2 minus 1 over 2 squared, and that will give me 1/4. So again, it's going to look similar to this one. It will just be headed in the opposite direction. So there we go, slope of 1/4. And then my last one, I've got negative 1, 2. So dy dx will equal, again, 2 minus 1 over negative 1 squared, which again is 1. So again, my slope is going to be 1. Okay, and what I'd suggest on this one, especially if you have trouble drawing the slants, notice how I actually showed whoever's reading my paper what slope I had intended for it to have. So that was kind of helpful, I think. All right, this was worth 2 points. If you have your 0 slopes right, so if you have all these having a 0 slope, you're going to get +1. And then all the other slopes, if you had all the other slopes right, that would be worth another point. Okay, part B. Find the particular solution to the differential equation with the initial condition f of 2 equals 0. The second that you see the words particular solution, you better be looking for an equation that you can cross multiply. And I definitely see one right here. We can definitely cross multiply on this one. So I'm going to get dy over dx is equal to y minus 1 over x squared. Cross multiply, we'll get x squared dy is equal to y minus 1 dx. And now I notice my variables are not on the right sides. So I'm going to divide by x squared first. So I'll get dy is equal to y minus 1 dx over x squared. And now I will have to divide both sides by the y minus 1. So now I have dy over y minus 1 is equal to dx over x squared. Right? Now we're ready to take the integral since both sides have the right variables on them. Okay, on the left side, since I have something in the denominator, I'm going to do a u substitution. U will be y minus 1. Du is going to be 1 dy. And notice I've got everything there, so this is actually turning into a du over u problem, and the integral of du over u is just ln u, so it'll be ln y minus 1. Okay, the right side, we're going to rewrite it first. We're going to rewrite it as x to the negative 2 dx, And so now from here, I'm going to increase my power by 1, so I'll get x to the negative 1, and then the reciprocal of negative 1 is just negative 1, so this will be negative 1 over x plus c. Right, my next thing, as long as we have the ln by itself, we can go ahead and do the logarithm loop. So I'm going to get c e to the negative 1 over x is equal to y minus 1, and then I'll add 1 to both sides. So I'm going to get y equals c e to the negative 1 over x plus 1. Okay, from here, hopefully you remembered that plus c, because otherwise you are messed up on points at this point in time. All right, we need to find c. They did tell me that x is 2 and y is 0. So we'll put 0 equals c e to the negative 1/2 plus 1. We're trying to solve this for c, so I'm going to subtract 1 from both sides. So I'm going to get negative 1 equals c e to the negative 1/2. To get the c by itself, I'm going to divide both sides by e to the negative 1/2. And then on this side, so we're going to get c equals, since I have e to the negative 1/2 down below, if I move it up, it's going to become positive. So the c is actually equal to negative e to the positive 1/2. Right? So if I rewrite this formula now, I'm going to have y equals negative e to the 1/2, e to the negative 1 over x, and then plus 1. Right? This is a totally acceptable answer. If you wanted to clean it up a little bit, since we have two bases that are both e's, we could add their exponents. So another way of writing this answer would be y equals negative e to the 1 over 2 minus 1 over x plus 1. That is definitely not a necessary step. It just makes it look a little bit nicer. Okay, that problem was worth 6 points. If you separated your variables, which I did kind of in this whole process right here, that was worth a point. If you correctly took the antiderivative of both sides, if you correctly took the antiderivative of the left side, give yourself a point. If you correctly took the antiderivative of the right side, give yourself a point. If you put plus c, give yourself a point. And then if you found c, which we did, give yourself a point. And then if you got that final equation, either this one or this one, you got your final point for that one. Okay? All right, last part is part D. All right, it says for the particular solution that you found in part B, find the limit as x approaches infinity. All right, so we're going to find the limit as x approaches infinity of this equation right here, negative e to the 1/2 minus 1 over x plus 1. All right, so if we're letting x approach infinity, we're going to let this number right here get bigger and bigger and bigger and bigger. All right, so from here, we are going to get, as the x down there is going to get bigger and bigger and bigger and bigger, this fraction is actually going to get smaller and smaller and smaller and smaller, and it's going to approach 0. So I'm really going to be left with negative e to the 1/2 plus 1, and that is the answer, because I don't have an x in the problem anymore, and that's my limit. All right, that was worth just 1 point. Either got it right or got it wrong.